Hey guys, welcome to another video for Algebra 1. So in this video we're going to be looking, now I'm going to need you to have your books out. Okay, so if you don't have your books out with you right now, go ahead and get those, pause it, and go get your book. And so in your book, I want you to go to page 181. And I'm going to be going through some of the key concepts um, for lesson 5 in chapter 3. And the title of this lesson is Transformations of Linear Functions. So transformations, essentially what we're going to be looking at in this lecture is what happens to the function that as you manipulate the slope and the y-intercept. Okay, now a lot of these manipulations you're kind of already aware of, but we're going to just deal with them specifically as to what exactly happens, how the function or how the line, so anytime I say the function, I'm referring to the line on the graph, okay, the line that results from your equation. So if you look over here a bit on the left, you'll see the y equals mx plus b, the m in green and the b in purple, and you're going to see as I scroll around and move around the m, that's going to change the slope, right? So right now I'm going to have it at 1, a standard slope, 1 over 1, and then you'll notice here on the b, I can manipulate that and that changes my graph there too, okay? So I'm going to have it at a slope of, not a slope, but a y-intercept of 0, okay? So let's take a look and see how if I change either one of those terms, how if I change one of those terms, it can manipulate the function on the graph. So if you're looking on page 281, let's look at the first key concept. And we're looking at the top left, the vertical translations. Okay, so I'm going to try and simplify this. So vertical translation meaning how I can manipulate this equation to make the graph either go up or go down, and I'm going to make it go up and down in relation to the y-axis. Okay, so for example, and the y-axis, you know that wherever the graph crosses the y-axis, that's the y-intercept, and that's what is represented by b. So how can I make it go up or down? So you'll notice as my y-intercept increases, my graph also is vertically translated up. So plus 3, it's a vertical translation of positive 3. I can go negative, so negative 1, and it's vertically translated down, right? So that's that right there. Now, something to keep in mind too is that there's another way to look at it. It's all about perspective here, right? And our perspective, our point of reference has been the y-intercept. You can also do it as you can do a horizontal translation, having the x as your point of reference. At the end of the day, it's actually the same thing. Okay, so for example, in your book, you'll see here on page 81, the bottom ones, the horizontal translations. So for example, the horizontal translation on the bottom left is the exact same thing as a vertical translation going down on the top right corner. So you see how look at the two boxes diagonally? The vertical translation going down is the same thing as the horizontal translation going to the right. Okay, so they're actually the same thing. And in fact, when you look at the equations, if you look at them with the scope of a y equals mx plus b scope, you end up with the same result. So let me do an example for you so you can see how that works. So if you go to page 182, look at page 182 and look at example number 1. Look at example A. It says g of x equals x minus 2. So that x minus 2, if you flip back to page 181 and you look at the horizontal translations, so if your function is a fx minus 2, which is what's going on in page 182, it says x minus 2, right? X minus h. So the h represents the 2. So that negative 2 on the x means that the line will be going to the left. I'm sorry, it'll be going to the right 2 times, right? So this line will be horizontally translated to the left. That's if you look at it that way. I think there's a much simpler way to look at this, and if you look at g of x equals x minus 2, why not look at it as your slope-intercept? The g of x can be y, right? Y equals x minus 2. So your slope is 1 over 1, right? And your y-intercept is negative 2. So let me change my y-intercept to negative 2. See? So if you look at my y-intercept, if you look at where I crossed the line, it's negative 2. But then if you look at the x-intercept, it's positive 2, right? So and if you go back to your equation on page 182, it's g of x equals x minus 2. So again, this can be looked at as a horizontal translation to the right because of the minus 2. The minus 2 means I move to the right 2, so plus 2. All right. And the other way to look at it, which I think is easier, which is the way I've been kind of training you to do, is look at it in the scope of slope intercept. This minus 2 is just your slope intercept. Your y-intercept. So why not just go down? So go down 2, and when you draw your line, it ends up with the exact same result. Okay, so look at letter B on page 182. Same thing. Okay, so let me go back and change this to 0, but it's the same thing. So I have x minus 4, right? So if I look at it through a horizontal translation, the minus 4 tells me that this x-intercept needs to be at positive 4, right? Which is the same thing as changing my y-intercept at negative 4, which is how I can read it. If I look at letter B, 182. Okay, I know it's in parentheses, but there's an assumed 1 outside that parentheses, right? So it's just 1x minus 1 times 4 is 4, so x minus 4. So the slope is 1 and the y-intercept is negative 4, which is right here. So it's vertically translated down 4, or you can read it as horizontally translated 4 to the right. Either way is correct, but like I said, there's one way that you've been looking at this already, and that's through y-intercept, slope-intercept form. So that's for the horizontal. On page 181, you have the horizontal translations and the vertical translations. Depending on how you look at your function, it'll determine how your graph looks. So just to make sure, I want to do, because if I was in class with you, I would do a couple more examples. So I want to do a couple more examples. Let me change it back to the standard form. If you go to let's go to page 186. So go to your book on page 186. Okay, so in your book on page 186, also guys, if I'm going too fast, feel free to pause me, to rewind or fast forward or whatever the case may be. So right now we're on page 186, and I'm looking at number 1. It says g of x, and then parentheses it has x plus 4, right? So there's nothing to distribute outside the parentheses, so it's just x plus 4, right? So again, if I read it in my slope-intercept form, that plus 4, I'm going to change my function to plus 4 because that's what the equation reads. If I read it as plus 4, right, I vertically translated it 4 units up. But if I look at it from the horizontal translation, that plus 4 means I have to go negative 4, which the x-intercept is negative 4. Okay, and that's the 0. Okay, so when I say if I'm zeroing the function, what I mean by that is that I'm looking for the x-intercept. So it's going to essentially be whatever the opposite is of whatever the function is telling me. So number 1 said x plus 4, so that means it's the opposite. The x-intercept is the opposite, negative 4. Okay, now we'll deal with that in greater detail later on. Yeah, we'll deal with that in greater detail later on because there's a way to work those out where you find the 0 every time. But for now, we'll just keep it to that. So now look at number 2, g of x, x plus 7. So again, if I'm looking at, I can't go beyond that, I guess. Yeah, it won't let me go beyond. Oh, maybe it will. No, it won't. So if it's plus 7, then I know that it's got to be minus 7 all the way to, it's got to be, the x-intercept has to be on the 7 over here, right? But if I read it just as y-intercept, then plus 7, actually plus 7 is way up here. Yeah, plus 7 is minus 7. It should have been over here, the x-intercept. But plus 7, that means my y-intercept will be up here. My y-intercept will be plus 7, and my x-intercept will be minus 7. So it's opposite, right? And that's not the case every time. This just happens to be the case right now because my slope is 1 to 1. It's a 1 to 1 ratio. So whatever my y-intercept is, my x-intercept is going to be the opposite because of that 1 to 1 ratio. Okay? So let me move on to the next idea. So now I'm going to page 182. And if you see on page 182, halfway down, it says dilations and reflections. So dilation. Okay, think of the word dilation. Like with the eye, when your eye dilates, it opens up, okay? And when it constricts, it closes down, right? So how can I make my function dilate or constrict? So I'm going to pick my formula or my function back at 0, okay? So my slope, my y-intercept is 0. So I want it to dilate. So dilation refers to the number you're going to be focusing on is the slope, the b. So anytime your slope is greater than 1, notice what happens to your function. I'm increasing it. It's going greater than 1. So now I'm at 2. I keep increasing, I keep increasing, I keep increasing. And so what happens to it as my slope increases greater than 1? Okay, so as my slope increases, it goes greater than 1, it dilates. Okay, it's a vertical dilation. It goes up. Okay, it goes up. So now notice what happens to my function as my slope goes down. So now I'm at 1. So now look what happens when it goes to below 1. Anytime your slope is below 1 or a fraction, it flattens out. And it makes sense because what's a zero slope? It's just a flat line. It's 0, right? So that stands to reason that anything just above 0 is going to be just a slight increase, a slight slant. And the bigger the number gets, the greater the slope, right? The more the vertical dilation. And as it goes below 1 and below, it becomes more of a horizontal dilation, okay? And then eventually it'll be 0, where there is no slope at all, okay? So let's talk about reflection real quick. Well, you know what? Let me do just like with the previous. I want to do 2 examples from the book also. So let's see here. I'm looking at your book, and I want to see where I can find problems to work on for dilation. There's not really anything there just right off the bat. So I'm just going to do examples from what's on here. So page 183, look at example number 2 on the right. So it says g of x is half of x. Half of x. So I'm going to do, my slope is half. So, oops, it's negative. Look at, it's 0.5. So 0.5 is not as steep as 1. It horizontally dilates, so it's below 1. It goes down. It becomes less steep. Now, what about part B on page 183? Part B is p of x equals 3x. So now I'm at 3. So now you can see that my slope is a lot steeper. So, basically what this can do for you is that if you understand this concept, you can guess just by looking at the equation, the mathematical numbers and terms, you can have a really good guess as to how your function is going to look. Will it be steep or will it be kind of flat? And you know that if you have a 0 slope, then you know that's going to be a horizontal line, right? So, all right, let's look at reflections. So I'm going to put this back in its standard form. Okay, so 1x, so 1 over 1, right, for my slope, and it's at 0, 0, my point of origin, or my y-intercept is at 0. So what happens when it's reflected? Think about when you look at the mirror, it's a perfect reflection of who you are, right? But it's opposite. It's opposite. It's inverse. So if I look at this particular one, if I look at page 183, the key concept, reflection across the x-axis, okay? So if it's below 0, so I'm going to do a below 0 reflection, okay? So if this is 1, look what happens when my slope becomes a negative 1. Okay, you may not have noticed what happened there, but my previous line was right down here, so it made an X. It's a perfect reflection off of the off of the x-axis or y-axis, I suppose, depending on your reference, right? Because it can be, if this line was here at one point, now it's reflected here. And if it's here, then it's reflected over here across the y-axis. So the way to get a reflection is to basically have the inverse of that slope, okay? And a reflection is going to be 90 degrees. So these two lines, so the reflection of +1 is -1, and it's going to go straight down. It's going to make a perfect X. And the angle between those two lines is going to be a perfect 90 degrees. It's a perfect reflection or a perfect inverse of the slope of the previous line. Okay? All right. So that's that. We've completed the concepts for section 5 in chapter 3. So what I would like for you to do now at this point for classwork is do page 186, numbers 1 through 25, and let's say do the odds. Okay, do the odds. So that'll be due on Monday when I see you guys again. Alright guys, good luck in your studying.